Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which removes BST keys outside the given range. First, let us take an example. For example, if the range is from -10 to 13, the keys outside the range are removed and the modified tree is given below. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We take range as 11 to 19, so we pass 11 to min, 19 to max and 15 to root in the remove outside range function. Since root is not null, we fix the left and right subtrees of root. So first we pass the left child of 15, which is 10, using a call stack. Again, as root is not null, we pass the left child of 10, which is null. So root will point to null. As root is null, we return null to the previous call. Execution for node 10 is resumed and now we pass the right child of 10, which is 12. So now root will point to 12. Again, as root is not null, we pass the left child of 12, which is null. Since root is null, we return null to 12's left. Next, we pass the right child of 12, which is also null. Again, as root is null, null will be returned to 12's right. Now it is time to fix node 12. We check if root's key is less than min. As it is false, we check if root's key is greater than max. Since it is false, we just return root to the previous call as it is inside our range. Execution for node 10 is resumed and now we fix node 10. Since 10 is less than min, we create a node rchild which will point to 10's right. Next, we delete 10 and return rchild. So 12 will be returned to 15's left. Execution for node 15 is resumed and now we pass the right child of 15, which is 20. So root will point to 20. Again, as root is not null, we pass the left child of 20, which is 16. So root will now point to 16. Since root is not null, we pass the left child of 16, which is null. Since root is pointing to null, we return null to the previous call. Now we pass the right child of 16, which is also null. As root is null, we return null to the previous call. Now it is time to fix node 16. Since 16 lies between 11 to 19, we return root. So 16 is returned to 20's left. Execution for node 20 is resumed and now we pass the right child of 20, which is null. As root is null, we return null to the previous call. Next, let us fix 20. Since 20 is greater than max, the last if condition gets satisfied and we create a node lchild which will point to the left of 20, which is 16. Now we delete 20 and return lchild to 15's right. We have the final output. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.